Our third method of multiplication is called the area. Whoa, spelling much? See, that's why I teach math, not reading. Area model. You call it area model or area model method. Now, the thing about the area model, there's a couple different versions of it, and it applies differently when you're working with 2-digit numbers, 3-digit numbers, so on and so forth. I'm going to turn a little bit to see me. Now, the area model, it relies on some basic geometry, which I'm going to ask you real quick. If I have this rectangle, and let's say it's the floor in a kitchen that I want to do hardwood on, right? How do I figure out how much flooring to buy to cover this? How do you find the area of a rectangle?
Length times width.
Good. Length times width. Perfect. Or you can do length times width, whatever you want. We're going to say area equals length times width. Everybody with me so far?
Yes.
All right. Now, here's where decomposing your numbers meets area model meets partial product. I'm going to redraw this. I don't like the shape of this. I want it to be a little bit bigger so I can have bigger numbers. Is that okay?
Yes.
All right. So our number is 24 times 15. If I were to ask you what two numbers make up 24, what two numbers can you add together to make 24?
12. 20 plus 4.
You were about to say 12 plus 12. That's viable. 20 plus 4 is really what we're looking for because we want to look at our place values. You break it down by your tens and your ones and your hundreds and your thousands, right? So 24 is made up of 20 plus 4. I want to write that across the top. 20 plus 4. Good?
Okay.
What about 15? This one's for Trish.
10 and 5.
10 plus 5. Right on. Good. Now, remember like we said, area is length times width. We're going to multiply length times width. Only what I'm doing is I'm going to kind of put some lines on here to help separate my numbers. And you'll see how this makes sense in a minute.
Okay.
I'm leaving this here because we're going to need that in a moment, okay?
Okay.
So length times width. Now I've got 2 widths and 2 lengths, don't I?
Yes.
We're going to do one at a time. Easiest to start with your ones or your tens. It doesn't really matter, whatever you're most comfortable doing. I'm going to do the closest one. What's 10 times 20?
200.
200, right? So that goes in that space. That area is 200. Now, 10 times 4.
40.
40. Boom. Look at these numbers coming along. 240. Right? How about this one? 5 times 20.
100.
100. And 5 times 4.
20.
20. Boom. Same numbers. 120. 120. We good so far?
Yes.
And now this part is where a lot of kids like it, especially if you have a kid who's a visual learner more than, abstract in the mind. They need to see stuff to help figure things out better. Because now you can take this and you can add the numbers together either across or down, whatever makes sense. I don't have a lot of room here, so I'm going to add down to the bottom. Let me adjust the camera so we can see this okay. That good?
That's good.
So we're going to add these numbers first of all. 200 plus 100 is?
300.
300. Now, if I went this way, 200 plus 40, I'd put 240 right here, wouldn't I?
Yes.
Tomato, tomato. You can go either way. 40 plus 20. What's 40 plus 20?
60.
So now we've got 300 plus 60, which is what?
360.
360. Same answer as our partial product, right?
Yes.